Okay, so you have to use non-parametric analysis. Um, so we go back to our diagram here, telling us which analysis we can use. And if you look particularly in this box here, I've listed 4 of the most common type of analysis. And let me tell you a little bit how they correspond to different scenario and to their parametric equivalent. Um, so here we first have the Mann-Whitney test. It's a little confusing here because the Mann-Whitney also can be called a Wilcoxon. So the Mann-Whitney can be called a Wilcoxon rank test, and here it's Wilcoxon signed rank test. Um, so don't get confused by that. But basically, they correspond to a t-test or a paired t-test. Okay, so the fact that it's signed here means that you take the difference between the two values. Okay, so Wilcoxon or Mann-Whitney, they're the equivalent of the t-test. Then you have the Kruskal-Wallis. I think that's probably one of the most common type of non-parametric analysis. It's the equivalent of a one-way ANOVA. So the advantage over a Wilcoxon is you can have 3 different groups. So you still have one independent variable, one dependent variable, okay? But the independent variable can contain more than 2 groups, whereas here t-test is always, or Wilcoxon, it's only 2 groups, okay? So the Friedman test is a little bit the equivalent of a two-way ANOVA, except that one of the factors is a repeated measure. So it's a little bit like a paired design kind of analysis. So you have one independent variable that's sort of a regular thing, like your treatment. You treat mice with treatment A, B, C. You're trying to figure out if the treatment has an effect, but you might take measurements at 3 points in time. So it's repeated measure. And so the 3 points in time would be your second factor. You could imagine, for example, that depending on when you take the measurement, maybe the effect is more and more pronounced. Well, the analysis will take that factor into account, but it doesn't give you a p-value for the effect of that factor. It just removes this factor and then look at the effect of the main factor if you want. Okay, this is an example, just sort of global understanding of the mathematical basis of these non-parametric analysis. And mostly I want to compare it to your parametric analysis. So here you have a t-test, and so we know that basically these t-tests or ANOVA are based on looking at the difference in their mean and their variance. So is the variance of one compared to the mean bigger than the variance across means or across groups? And so you can figure it out based on that. A Mann-Whitney test, for example, or a lot of the non-parametric analysis are based on ranked data. So here you have 2 groups. You rank your whole data set from the sample with the biggest measurement to the sample with the smallest measurement, and you look at here you see the rank sum. So the sum of the ranks. If you have one groups, they're all in the biggest samples, and in the other groups, they're all in the smallest sample, while the rank sum is going to be very different for the 2 groups, and so you can figure out that way if you have or not a difference between your 2 groups. Okay, so make sure you understand these concepts, and let's next use a little bit at how we can use these analysis practically.